Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 5D assignment. Start here with number 1. Consider the data set below. Part A, draw a scatter diagram for the data. So here's our X and our Y. The maximum highest X we have is 10, lowest is 1. And then for Y, it looks like the highest is 20 in 2 different spots and the lowest is 2. Okay, so since our highest on the X is only 10, I'm going to do, and I know that this is 20 lines wide, I'm going to do 1, 2, 3, like this, because this way I'm guaranteed to get some of my data on the second half over here. And then since this goes from 2 to 20, I'm just going to do this by every one of these lines is 1, so I'll just do 2, 4, 6, 8, all the way up to 20. Okay. Now, once we have this all taken care of, what we can do is we can start by graphing these, but maybe even, let's see, normally we'd want to put some kind of like title and label our axes, but really this is just X and Y, right? That's X and that's Y. That's about as much as we can label. So now we can graph each one of these points. So X is 10, Y is 20. That is this point way out here, and then we can go through and graph all the rest of those as well. Okay, so here's all of our points all graphed here. Now what we want to do is it says use technology to find the equation of the regression line. Plot the line on your calculator. So to do that, we are going to want to pull up our graphing calculator, stat, and we're going to edit. And we're going to most likely already have data in there, so you got to clear the data out. And then we're going to put all this into our list 1 and all of this into list 2. Okay, once we have all of our data in here, now we can hit stat and we are going to calculate. And we want the regression line, so we want to do our linear regression, which is number 4. All right, so X list is 1. List 1, Y list is list 2. Frequency list has to be cleared out if there's anything in there because we don't have frequency on this. Enter, enter, enter. And our regression line gives us, it says Y equals AX plus B. And it says A is 1.92 and the B is negative 0.0667. So our equation is going to be, say, let's just go with 1.9 because 1.92 is going to be a little trickier. So we get Y equals 1.9 X minus, it was 0.667, so let's go 0.7. That's going to be our equation of our line there. Okay. Back of the book does leave it as 1.92 and 0.667. Oops, I messed that up. 0.06. They've got 667 or 0.67. 1.92 X. 1.9 would be fine as well. Anyway, so now we can use this to draw the regression line on your scatter diagram. So negative 0.06 is going to be really close to 0, right about, say, there, right? And then what you could probably do with this, if you want to really get a good line in there, let's change our colors here just so we know what we're doing here. So there's our negative 0.06. And then what I could do is I could plug in 10 for X. So we get Y equals 1.92 times 10 minus 0.0667. Right, so that is Y equals 19.2 minus 0.0667. So that's basically 19.1 or so if we go through and subtract that out. So at 10, we're up at about 19. Okay, so there's about 19.1. Now we have two points there, and now we can just simply connect our two dots. Okay. Now, if this was a line of best fit, that's where you want to make sure that you find the mean point, and the line of best fit has to go through the mean point, but this is not that, so we don't have to worry about that. C, use B to draw the regression line on your scatter diagram. We just did that. Okay? All right, so that's number 1. Next one to take a look at is number 3. Table below shows the price of petrol and the number of customers per hour for 16 petrol stations. That's all this here. Calculate the Pearson's product moment correlation coefficient for the data. All right. Okay, so then what we're going to want to do is we're going to want to enter all of our data here into, oops, sorry, oh, that's not what I wanted. Okay, that's better. So we're going to want to enter all this data here into our graphing calculator. So stat, edit, and then we're going to put it in all of our data here into these 2 lists, right? So this will be up here, list 1, and this is list 2. This is the X and this is the Y. All right, so we're going to go through, enter all that data in. Okay, so we have all of our data in here. Now it says calculate Pearson's product moment correlation coefficient for the data. That's just the R value. We've done that lots of times before, but that's the Pearson's product moment correlation coefficient is just the R. Okay, so what we want to do, stat, calculate, and we want to do our linear regression. Okay, X list is list 1, Y list is list 2, frequency list has to be clear, and calculate. And here is our R value, negative 0.924. Negative 0.924. Okay? Now, describe the relationship between the petrol price and the number of customers. So it got a strong, because it's 0.92, negative correlation, right? So that means as the price goes up, the number of customers will go down. So like if you look at the ones with the high, like 110 is only got 12 customers, 109 is 17. Then you get the low ones, 102.9 has got 50, 104.5 has got 48. Okay, so the lower the price, the more customers. So describe the relationship between the petrol price and the number of customers. Again, the higher the price, the lower the number of customers. Okay, so the relationship is strong negative. The higher the price, the lower the number of customers. Okay, C, use technology to find the equation of the regression line. Well, guess what? That's what we just did right here. So we have our regression line. So Y equals negative 4.267, we'll call it. So we get Y equals negative 4.267x. And then our Y is 489.4, we'll call it, plus 489.4. Is that what we came up with? Yeah, 489.4. Negative 4.2269. 226. Oops, 69, not 67. Okay. Now it says state and interpret the gradient of the regression line. So the gradient is negative 0.269. Interpret the gradient. So that means for every penny the price goes up, they're going to lose about 4.3 customers. Okay, E, estimate the number of customers per hour for a petrol station which sells petrol at 115.9 cents per liter. Okay, so really what we can do is we can plug that into our equation here. So we have, I'm going to put that over here so we can work it out. So Y is our number of customers. That's what we're looking for. So Y equals negative 4.269 times 115.9, because that's our price, is our X, plus 489.4. And now we're simply just going to calculate that out. Okay, so we do negative 4.269 times 115.9, and then we're going to add 489.4. 489.4 customers. So they should expect to have -5 customers. Okay. -5 customers. Obviously, you cannot have -5 customers. So it does say comment on the reliability of your estimates in E and for F. Okay, let's see. Oh, sorry, this was -5 customers was for E. So F, estimate the petrol price at a petrol station which has 40 customers per hour. So to do that, so this -5 is for this. And to do the 40, we're going to plug the 40 in for Y. So 40 equals 4.2, negative 4.2. Let's write that so we can see it better. -4.269x plus 489.4. So then what we're going to do is subtract 489.4 from both sides. And we get -4.269x is going to equal whatever this is, 40 minus 49.4. Gives us -449.4. Divide both sides by -4.269. All right, so divide by -4.269, and we get about 105 customers. Okay. Oh, no, sorry. Not 105 customers, but the price will be 105.3, we'll call it. 105.3 cents, not dollars. Let's get rid of that. Okay, so 105.3 cents per gallon is what that is saying. So comment on the reliability of your estimates on E and F. Obviously, you cannot have -5 customers. So if it's 115.9, they're probably not going to have any customers probably at all. Okay, and then so since this 105.3 cents actually lies within this range, this is probably, and this 40 customers is also within this range. It's interpolation, so this is probably going to be a pretty reliable estimate there. Okay? All right. Last one, number 7. The yield of pumpkins on a farm depends on the quality of fertilizer used. Draw a scatter diagram for the data and identify the outlier. So we'll do a scatter plot for this, and then we're going to do all this other stuff here. Okay, on this one here, got to find the low and the high. Low 1.8, high is 5.7, low is 4, and the high is 50 for the X. So let's see, this is out to 20, so we'd want this to do maybe, got to go all the way out. This is 20 total lines. I got to go all the way out to 50, so maybe have each of these be like about, say, 6. Wouldn't that work? We'll have each one of these be 3, so we'll do every other, like, say, 6, 12, 18, so forth and so on. And then for the Y, 1.8 to 5.7, that's not a big range, so we can really look at this as, like, almost think of that as 60 like we did this. But it's, so we'll actually just go by, instead of 3s, we'll go by 0.3s, okay? Okay, so now we have our graph set up, so now we're simply just going to graph each of these points. So we got 4 and 1.8, so that's going to be about right here, and then we can go through and graph all the rest of those points too. Okay, so here's what the data all looks like there. Draw a scatter diagram for the data and identify the outlier. So this here is our outlier. Okay, because it does not quite fit with all the rest of the data. But honestly, that could be a realistic piece of data, because chances are, like, I mean, you can like this, like the more fertilizer you're putting on, the higher the yield. But if you overdo the fertilizer, it's going to end up dropping back down anyway. But for what we're looking at here, we want to look at just this line here. So we're going to drop off that that outlier, which is this one right here. This is our outlier. All right. Now, what effect do you think the outlier has on the strength of the correlation of the data? So obviously, with that outlier in this data line here, our correlation coefficient is going to be much lower. Okay, and then the gradient of the regression line, this data point here is going to flatten the gradient out. It's going to, like, we know that it should go like this, but with this data point in there, it's probably going to go underneath some of those points like that. So it's going to flatten out that regression line. So we're going to actually calculate the correlation coefficient with the outlier and without the outlier. So to do that, bring up our graphing calculator, stat, edit, and we're going to put all of our data here in our lists. Okay. So this is all of our X, this is all of our Y. Okay, so here's all of our data entered in here. Now, one little quick side note here, if we know we're going to find the correlation coefficient with and without the outlier. Let's say this piece of data was over here somewhere. If I knew that was going to be the outlier and I was going to need to calculate it with and without the outlier, I would move this outlier piece of data to the very end, because it's a lot easier to delete these off of the end than it is out of the middle. Okay, so anyway, let's calculate the correlation coefficient with the outlier. So we will do stat, calculate, and it's our linear regression, right? We're going to see how well this fits into a line. Make sure the frequency list is blank. And our correlation coefficient is 0.798. So 0.798. Okay. It also says calculate the equation of the regression line with the outlier. So since we already have that right here, let's put that in there before we take our data out. So the regression line is 0.067. 0.067x, and then the b is 2.22 plus 2.22. There's our regression line with the outlier. Okay, now we're going to go back in here and we're going to go into stat, and we are going to edit, and we are going to get rid of the last piece of data because that's our outlier. So we do that and we have to push delete. Go over there and push delete. Clear, I've found, does not work. Stat, go over to calculate. We'll go down to linear regression, and then we recalculate everything. Or the calculator recalculates everything for us. Okay, and now the R value is 0.993. 0.993. And then that regression line without the outlier is 0.119 x plus, and then our y-intercept was 1.32. Oops. 1.32, is that what we said? 1.32. Okay, so there's the correlation coefficient and the regression line with and without the outlier. Now E says if you wish to estimate the yield when 15 grams per square meter of fertilizer is used, which regression line form should be used? So 15, basically this looks like this line's going to work up until about at least 36. So since this 15 is down here in this range here, we're going to want to use the one without the outlier. Without the outlier. All right, sorry, that's this one over here. We want to use the regression line without the outlier. Explain your answer, because that is within this data range right here. Again, as soon as you get past, it looks like when you get past 35, then the data starts to fall apart. It starts to make it probably worse. So as long as it's from 0 to 35, and 15 definitely fits within 0 to 35, then we're going to use the without the outlier regression line. All right. Can you explain what may have caused the outlier? We talked about that already. If you over fertilize, it might end up starting to kill the crops off because you can have too much of a good thing, right? Do you think the outlier should be kept when analyzing the data? As long as the data is between 0 and 35, I would get rid of the outlier. If you start going past that, I think you're going to have to come up with a whole different equation. So honestly, I don't think the regression line with the outlier included is going to help for anything. But this data here is going to help out as long as the fertilizer is between 0 and 35. And that's grams per meter squared. Grams per meter squared. Okay. All right. I think that's really all we have for this here. If you have any questions on any of these other questions that we went over or anything else in the assignment, please feel free to ask. Thanks.